Hello, hello. Today we're gonna do bubbles in a pink sphere, and we're gonna render it with Octane. Let's start with the Geo node. I'm gonna call it bubbles source. Dive in and create a sphere. Set the scale to 2. Primitive type, polygon, frequency 64. And we're gonna make 2 branches. One and the second one. The first one is gonna be a ripple solver for the surface, and the second one we're gonna use to scatter some points. Let's start with the scattering points. Use the peak node. Shrink the sphere a bit, just to make sure that the scattered points inside won't intersect with the exterior surface of the sphere. ADB from polygons. Type from distance to fog. Decrease the voxel size a bit and scatter some points. "65 points will be enough. Create a scale attribute. P-scale, and the value should be 0.1. Let's make a preview for that. GL sphere points equals 1. Okay, turn off the grid, we don't need it right now. And attribute adjust float to randomize the scale of the spheres. Attribute name p-scale, already the one that we need. Operation, multiply, pattern, noise. Ta-da! So we can adjust the element size for offset to 1.3 and maybe decrease the scale for the small spheres, and create another attribute adjust float and decrease the element size to 2 and set an offset to 0.2. Just to ramp a bit. Let's leave it like this for now. Maybe we'll come back later to adjust the scale. Let's scale the tiny particles with a blast node. And right here that if p-scale less than 0.1 and group type is points, then delete small particles. Maybe 0.2. Yes, like this. Then use the copy to points node and copy some spheres onto it. So the spheres are going to be smaller than our reference points scale, so we're going to adjust it by just scaling up the source spheres. Let's fix the type to polygon, so the polygons would be equally distributed along the surface of the sphere. Increase the frequency a bit, 4 is fine, and that's going to be it for our spheres. Then we're going to need a smaller spheres, another scatter. And then say 55,000 points. Don't really need the relaxed iterations here. Create a scale, a default one. Create a preview node, same as before, but the scale should be probably 0.01. That's better. So we can copy attribute adjust float here as well. Element size 1, offset 2.5. You can play with these to get different results. It's just the principle that's important. 0.75 offset 3. Maybe the scale should be a bit bigger. And maybe add another attribute adjust float with the tiny node size. Now we have some sort of bubbles that happening. Again, we have to delete the tiny points. We've adjusted the scale of the points, but the points are still there, as you can see. Now we can delete those tiny points, but not all of them. And maybe like this. So now we have 2000 points. That's fine. So we don't want the tiny spheres to intersect with the bubbles. So we have to delete the points that are now inside the spheres. To do that, we're going to use the group node. In the first input, we're going to connect the points. To the second input, we're going to connect the spheres. We're going to peak them a bit, so they're going to be a bit bigger. And I'm going to change the group type to points. Call it blast. Base group, we don't need that. Given boundary regions, boundary object. So, as you can see, some of the points are now inside the spheres, and we don't need those points. Blast. I'm gonna blast the group that's called blast. Nice. Now we can fix the intersecting points just by introducing the fuse. Click on the radius attribute, and that's gonna be it. Now we're gonna add this into a group. I'm gonna call it bubbles small. Okay, bubbles small. And now we can sim the thing. So for the big bubbles, we can use Vellum configure balloon. As is. For the smaller bubbles, we're going to use Vellum configure grain. As you can see, the scale has been lost. So we can untick the particle size, checkbox, and everything's going to be restored. So the next thing that we have to do is to connect this to Vellum solver. You can use two different methods, as far as I know. You can just merge the thing. So you just merge geometry, geometry, and you merge constraints with constraints, and then connect those two things accordingly. So this is geo, this is constraints. But this is annoying, you know. Also we can switch the types of lines, but this is no, just terrible. By the way, I do this a lot, but for the sake of tutorial, I'm gonna do this the proper way. Vellum pack. So this is gonna be a bit neater way to do the same thing. So you just pack the thing, merge the thing together, and then you unpack it. Vellum unpack and Vellum pack. Way better. I'm gonna feel like a different person. Now everything is connected. If we press play, everything should fall down. No, it's even worse. It's not working because by default the grains are supposed to be the same scale, and they are not. So we have to go to Vellum Solver, Advanced tab, and uncheck Assume Uniform Radius in the Green Collision tab. Yay, something's working. We also can check if the sim works. Just creating a ground plane, moving it a bit lower, and pressing play. This works. Looks pretty bad, but who cares? They interact, and that's all we need. Also have to fix the frames per second. It's not a movie. 30 FPS. Nice. So right now I'm gonna uncheck the gravity tab, set it to 0, and add some wind. Pop wind 0.15. Amplitude for the noise 0.3. Swirl size 0.25. Pulse length 2. And we're also going to use our sphere as the collider. Called collider. Instead of dragging the collider here, like this, I'm just going to use the object merge node to keep things clean and color these to purple. Sphere, collider. Like this. So right now, oh my god, this is terrible. This is why I was doing the peak. Should have probably used the bigger values. Yeah, probably. Anyway, with this fixed, we can check how the sim looks. These two are intersecting. Annoying. This is not a good thing to have. So, overall it works. We need to add probably pop drag. Little bit of drag. And we need to fix these things. Why that happened? Maybe change the global seed. Or just fuse them as well. You can use the fuse. So let's make global seed 0 again. We have two intersecting points, and then we're gonna fuse them using the radius attribute. Bonk. The simplest way. Okay. So now everything's working, but the spheres, the big spheres seems to be too stiff. We can decrease the stiffness in the cloth constraints, set the multiplier to 1 instead of 100. And now, yeah, they're gonna be wobbly. And this is nice. We can also add another drag to the system. I'm gonna group the points. Drag. Call the group drag, and this is gonna be a point group. Random chance, 25% of the points should be included. And the same goes for the tiny particles. So we have our another drag group. I'm going to add another drag here. So this is the drag that's going to be affecting all the particles, and this one is going to be affecting only 25% of the points. I'm going to select the group drag. Okay. And the air resistance should be like 4. Okay, so I'm gonna see the difference. Or at least I hope I'm gonna see the difference. Well, it's noticeable in the smaller particles. Is it? Is it noticeable? Why they're flying away? Hmm. Maybe the amplitude is too strong. Maybe the swirl size is too big. I like this motion. Boom, boom, boom. So yeah, these are gonna be our bubbles. I'm gonna cache it. I'll cache. We don't need any attributes, to be honest. Well, we do. We don't need most of the attributes. So we're gonna select only the attributes that we need. P-scale, velocity, and sphere points. So I won't have to remake it again. And I'm gonna cache it. Say Vellum, cache, bubbles, hip, sim, and 100 frames. Okay, with this cached. So this is cached, they move around. Looks okay. Maybe 150. Now, we can use the time shift. We can use the time shift and add 50 frames to our first frame. Gonna look like this. So they won't start from the beginning, but rather from the frame 50. Okay. Now we have to split these two into two streams. The first one's gonna be our small points. What? Sorry, bubble small aren't working because I forgot to change the group type to points. That's a rookie mistake. Now we have to reseam everything. Okay, so now we can separate the points, the big ones from the small ones, and I'm gonna do that because in some cases there are gonna be too many tiny spheres and you don't want to render them as spheres but maybe as instances because they aren't deforming and you don't need to use the real geometry. You can just instance the geometry on top of them or use packed geometry but not deforming geometry. But the other big spheres, you're gonna want to keep them as the real geometry because they wobble. So, I'm gonna have our big spheres, out spheres big, and out spheres small. So basically we're done with the geo and the sim, and I'm gonna leave it like this, and I'm gonna do the ripples on top of the sphere. We're gonna do it with the ripple solver. So we're gonna need the rest geometry and the deforming geometry. So this one is gonna be geo rest, and the second output is gonna be geo deformed. And I usually do it like this: attribute transfer, for example, some point, move it on the sphere surface, attribute create mask. Control click, middle mouse button, and enable mask attribute in the viewport. Mask, transfer mask, reduce the radius because this is huge. And this is our mask, and just gonna use the point wop and call it displacer. Displace along normal. and add a bind. We have to import our mask attribute and plug it into amount and promote the scale. The default scale is enormous. Whoa. .25 for default, and use the ripple solver. Rest geometry goes into the first input, deformed into the second one, and it should work out of the box. Looks fine, but we're gonna need a different sources. For that we have to create particle sim. Pop network. It's not as bad, but feels a bit excessive. Anyway, we plug our sphere surface into the first input, and now by default Pop network generates tons of points. We don't need tons of points. We don't need merge here as well. It doesn't do anything. So what we need is to decrease the amount of points to, say, 2 points. Set life expectancy to 0.1 and check it out. Okay, something's happening, and if we look at the deformed geo, sometimes something is popping out of the sphere. And if we check the ripple solver, it shouldn't work. It works because on the first frame the geometry is already deformed, but it won't see the next frames. It won't see into the future. You can fix that by checking the use input as animated displacement, and also check the ripple solver node. And as you can see, this is working. Looks excessive to say the least, but it's working. Okay, we can decrease the amount of displacement to some tolerable values. And maybe we can decrease the conservation from 1 to 0.9, and that way the energy of the wave should decrease with time, so it's just gonna disappear after a while. So this wave is moving, and maybe 0.8, and then it disappears. Okay, so depending on the look, you can tweak these things. You can tweak the amount of particles, you can tweak the amount of displacement. Maybe this is too much, maybe you need half as much displacement on the surface to make it look more elegant. Also, you can animate the displacement, so it won't spawn points, or I don't know, it won't, it will. I think you can just adjust the spawn rate of the particles. There's a source, there's a birth rate, and there's a constant activation, right? This one. And if you say activation equals $FF, if the frame is less than 100, then constant activation works. If it's more than 100, no particles gonna be spawned. Yeah, this is nice. Probably will leave it like this. Yeah, this is nice. You don't see the source points, but you see the waves. Doesn't look that bad. Maybe we can use the time shift and say this is our starting frame. So the starting frame would be 200. I already have the preset for it. So the $F is going to be added to our slider. So it's going to be 240. So this is going to be our first frame. Maybe 180. Anyway, add a null. And this is going to be our sphere base. So this is it for the base geometry. And as for the rendering, I'll see you in the next chapter.